In this module, I'm going to be covering the super important general chemistry topics of entropy, Gibbs free energy, and spontaneity. In this video, I'm going to be going over entropy, specifically the entropy of the system. So entropy, which can be denoted with delta S, can be broken down into entropy of the system and entropy of the surroundings. It's really important that you know the difference between the entropy of the system and the entropy of the surroundings to understand entropy as a whole. So entropy of the system, which can be denoted with delta S, system, is talking about the arrangements that we have in a system. So arrangements can be denoted with the variable W. So what does this mean? What does arrangements mean when we are talking about a system? So if we were to break this down into solids, liquids, and gases, how would the arrangements for each one of these systems change? So when we think about a solid, the molecules that make up a solid are very rigid and held in place. There is not a lot of room, there is not a lot of arrangements for those molecules that make up those solid to have. They cannot move around freely. So we will say that solids do not have a lot of arrangements. They cannot be arranged in many different ways. They are locked in place. Liquids, on the other hand, are more free to move around. They can take the shape of their container. They have a larger amount of arrangements. They have a greater entropy of the system than solids do. Gases have even more arrangements than liquids. Gases have the most entropy when we are talking about entropy of the system. So when we talk about entropy of the system, we are only talking about the arrangements that that system can have. So we can say that as we move from a solid to a liquid to a gas, the molar entropy, meaning per mole of that substance, increases. And again, this is delta S of the system. So when we discuss entropy of the system, we are talking about W, the arrangements of that system. So if we are met with a reaction, A gas goes to B solid, what happened? Did the entropy of our system increase, or did the entropy of our system decrease? Well, we started with a gas that has a lot of arrangements. It is very free to move around and make many different arrangements. B is a solid, which is very fixed in place, which does not have a lot of arrangements. So we can say for this reaction, our entropy of the system is negative. We lost entropy because we lost arrangements. So it turns out that gases have so much more entropy than solids and liquids that the entropy of a system can basically be determined by how much gas we have. So if we were to have a reaction, A gas plus 2B gas goes to C gas plus D liquid, and we want to know how much our entropy has changed in this system. When we look at a reaction, we only need to see the change in moles of gas. So entropy of system, or delta S system, can be determined by the change in moles of gas. So on the left side of this reaction, we have a total of 3 moles of gas, 1 for A and 2 for B. On the right side of this equation, we only have 1 mole of gas. So as we can see, for this reaction, we went from having 3 moles of gas to 1 mole of gas. Therefore, we lost 2 moles of gas. So we would say the delta S for this system is negative because we lost moles of gas. If we were to gain moles of gas, so if we started with a fewer amount of moles and in our product side we had more moles of gas, we would say that that system gained entropy. So as a summary, entropy, when we talk about entropy of the system, is talking about the arrangements that that system can have. We are basically talking about solids, liquids, and gases, where solids are very fixed in place and do not have a lot of arrangements. Liquids have a little bit more, and gases have a lot of arrangements, much more than solids and liquids do. So we can say, as we move from a solid to a liquid to a gas, the molar entropy of the system will increase. Then we looked at reactions, and we can tell the entropy of the system, how it will change based on the number of moles of gas in that reaction. So if the change in moles of gas is negative, we lost moles of gas and the entropy of that system decreased. We now have less moles of gas and less arrangements. If we were to make more moles of gas, I should say, the entropy of that system would increase because we would make more moles of gas, which would increase the number of arrangements we have in our system.